Hello from Australia, I'm Mark Horswill and I'm very sorry not to be able to come to ICTTP, but many thanks to Dick Laward for allowing me to submit this video presentation instead. What I wanted to do is show you some of our latest data on training hazard perception. So, hazard perception ability is the ability of drivers to anticipate potentially dangerous situations on the road ahead, and this has been associated with crash risk in an increasing number of studies, which raises the possibility that we might be able to reduce crashes by training hazard perception. So, hazard perception is typically measured using video-based tests in which drivers attempt to predict dangerous situations in traffic sequences filmed from the driver's perspective. In our particular test, you can see some footage of that behind me. Participants are told to predict potential traffic conflicts where the camera car is likely to have to brake or take evasive action to avoid a collision with another road user by indicating that relevant road user as early as possible, either by using a computer mouse or via a touchscreen. And we basically measure their mean response time to these hazards. Alright, so there's already plenty of evidence suggesting that hazard perception, or at least as measured in hazard perception tests, can be improved even with relatively brief instruction and training. In this talk I'm going to present data relating to our latest hazard perception training package. So this package consists of 3 video-based exercises, which I'll now show you some footage of. So essentially they are, first of all, people have to generate a commentary drive on some video footage, then they have to listen to an expert giving a commentary on the same footage, and then the third exercise is a video is paused unexpectedly and they have to indicate what will happen next, and then they hear what an expert predicts would happen next.
Commentary Drive Exercise 2. Start generating your commentary now.
Right, you'll notice some fade to black breaks here. They're just edits I made for this talk to save time. The full training package takes between 20 and 35 minutes to complete, depending which variation we're using.
Now it's the expert's turn.
Vehicles in front of us coming to a crest, difficult to see the traffic ahead. More vehicles in the distance. Car entering from the left and moving over to our lane, maybe intending to turn right up ahead, which will cause us to have to slow down. Checking the street on the left. Monitoring red car. Truck on the right waiting to turn, monitoring.
What happens next? Exercise 1. What happens next? Now it's the expert's turn.
There's a pedestrian crossing sign up ahead, and if you look carefully, you can see that there are people walking towards the crossing. We're in a school zone, so they're probably children. The vehicle directly ahead has already started to slow slightly and is probably about to stop to give way to children crossing the road. This means that we...
Now let's see what actually happened.
Okay, so we already know that this new training package here improves the hazard perception scores of young drivers who have ADHD, of all things. The question is, what else can it do? So, now on to our new data. It's one thing to improve the skills of people we know to be very poor at hazard perception, i.e. young drivers. However, the study I want to show you now was an attempt to see whether we could improve the hazard perception response times of the driver group at the absolute height of their hazard perception powers, namely highly experienced mid-age drivers. That is, people with decades of practice in anticipating hazards, whose hazard perception response times have not yet begun to slow with old age. So we tested 78 experienced mid-age drivers, and first of all they completed a pre-intervention hazard perception test. Then we randomly allocated them to either a training group who received a full training package or a no training placebo group. So this group watched the same videos that the training group did, but without any of the training materials, and they also watched video of training stuff which was nothing to do with hazard perception. Okay, following that, they then all completed a post-training hazard perception test, and then at least 1 week later we got them back again and tested their hazard perception a third time. And this is what we found. So the drivers who were trained were significantly faster than the placebo group directly after training here and after the delay. So this difference here is significant, and this difference here is significant, whether or not we control for pre-training and also controlling for things like simple reaction time. And notice that there's actually no significant difference between this training effect here and this training effect here, although it looks like there's a bit of a decay there. That's actually not significant. So that looks promising, in that we do seem to be able to improve at least the hazard perception test scores of even highly experienced mid-age drivers. However, one issue with driver training in general is that there is the potential for unanticipated negative effects. With some training, researchers have reported evidence that the road safety impact did not map on to the performance increase obtained from drivers, and one culprit suggested for this has been driver confidence. That is, training may have the dual effect of both increasing driver skill while also increasing driver confidence. And the problem with increasing driver confidence is that this can lead to drivers taking more risks, such that it can even negate or even reverse the safety benefits of the training. So it's a crucial question to determine whether our hazard perception training is falling into this trap. So to try and get a handle on this, what we did was ask the drivers in this study to rate their own hazard perception skill before and after the intervention. And this is what we found. So they're using an 11-point scale with the midpoint here anchored at the median driver. The training has basically no significant effect on their self-ratings of their own hazard perception skill, so it seems unlikely that training is boosting their confidence in their own driving skill. And overall, between these findings and other recent work that I don't have time to mention here, it appears that drivers of all ages have little insight into how good they are at hazard perception. So given the tendency for self-enhancement with driver skill, this could partly explain why the mid-age experienced drivers aren't as good as they could be at hazard perception despite decades of practice. That is, they already believe that they are pretty good and hence have no incentive to engage in deliberate practice to try and improve this skill. But could this current data just mean that participants don't actually believe that our hazard perception test is measuring real driving? That is, they may have realised that they were responding faster to hazards on the test, but just didn't think that this would transfer to their real-world driving skill. To check this, we also asked them directly about their performance on in both the pre-training and the post-training hazard perception tests after they had completed those tests. And as you can see, we get a similar pattern of results with no significant effects, no change following the intervention for either group. So that is, in this case, we're specifically asking them about the thing that we were measuring, the thing that we know from objective data has empirically improved, at least in the training group. So this is good. This suggests that confidence effects are unlikely to scupper potential safety benefits of hazard perception training. However, it might be bad in that this means it might be difficult to persuade anyone to engage in the training in the first place because they don't appear to be aware that it's actually having any effect on them. So that is, the training appears to be lacking some face validity. Now I want to show you another study where what this is very preliminary data involving the same training materials, but this time we're looking at drivers aged 65 and over, where critically we followed them up over a much longer time span. That is, we've got evidence that the training effects holds for at least a week. What about longer than this? Okay, so we've tested 76 drivers aged 65 and over. We give them a pre-training hazard perception test, and then we randomly assign them to training or no training groups as before, and then give them an immediate hazard perception test following this training, and then we bring them back after 1 month and test them again on hazard perception, and then give them a fourth hazard perception test 3 months after the original training. Here are the raw scores, but before you study this, note that interpretation here is annoyingly made difficult because we are unlucky enough to get a significant and substantial pre-training effects despite our random allocation to groups. So what I've done to make this data easier to see is I've subtracted all the post-training scores from this pre-training scores. Okay, so analysed in this way, we get significant training effects, huge ones straight after the training, but then we also get training effects at 1 month and training effects at 3 months. Okay, we get, even though it remains significant at 3 months, now we do have significant decay across this time span, so suggesting that any real world hazard perception training intervention package probably needs to be sort of repeated a few times in order to achieve a longer term effect than this. Alright, final study I want to show you. Basically, is there any evidence that the training that we're talking about here is changing any more than simply response times in the hazard perception test? That is, it could be that what the training is doing is just providing people with strategies to beat the test without necessarily meaning that they're actually detecting the hazards any earlier. Okay, so one way we tried to look at this was that we tested 46 novice drivers, and we assigned them to either the training or the non-training group as per usual, and then gave them a post-training test. But what we did this time was measure their eye movements while they were completing both those tests. And what we calculated from that was the time they took to first fixate on each of the measured hazards in the test. Here we go, this is the data from that. So this is the time to fixate the hazard, okay, where we do also get significant hazard perception response times differences as well. Okay, but the point is, as well as the faster responses to the test, people are actually looking at the hazards earlier as a result of the training. This is very preliminary data, and in fact we want to attempt to replicate this before we publish it because of various issues with eye tracking equipment, but at least this initial stab at it looks pretty promising. So to finish off, I wanted to highlight the current gaps in knowledge that we hope to plug in future research. First, we have a reasonable body of evidence supporting the idea that video-based hazard perception tests map onto real driving to some extent through crash risk associations, through novice experience group differences and so forth. However, there has been limited research, not no research, but limited research into whether these tests can directly predict on-road driving performance, so we wanted to test this out for our test. So we do have one research project where we have examined this, and hopefully we'll be able to release the results from that soon. Secondly, all of the training effects that I've shown you today are on hazard perception test scores, so it's entirely possible, even if we have a valid hazard perception test, it's entirely possible that these training effects may still not transfer to real driving despite those eye tracking results I've just shown you. So basically what we need to do is to directly test whether training impacts real driving, and ideally whether training impacts crash risk and road safety as well. Not a trivial task, but we're hoping to give that a go at some point. Right, third thing is if we do get this transfer with this existing package, obviously there's still presumably plenty of scope, latitude for improving this training. So we've got studies running at the moment where we're actually picking apart which aspect of the training is having the most effect. Also, given that we know that training does decay over, training effects seem to decay over time, one question would be how often and how much do we need to apply this training to people in order to achieve more of a permanent effect on their hazard perception. Note that because our training package consists of video stimuli and doesn't require either specialist equipment or even a driving instructor to be present, it could be potentially accessed via the internet at either negligible or zero cost. Right, fourth, the self-rating data that we found seems to indicate that drivers cannot detect when their own performance is improving, and while this might be good for avoiding problems of driver confidence, it could be bad in terms of drivers considering the training worthwhile in the first place. So if the training works, then I anticipate one of the next key lines of research will be to try and figure out how to persuade drivers to complete it in the first place. Thank you very much, and I would very much welcome any questions or comments that you might have.